Okay, so welcome to this build tutorial for the Digital Bird mini jib. I'll be breaking the build down into the different components. So the first thing we'll be handling will be the control box end, then I'll move on to the fulcrum, and finally the camera end and assembling the whole jib. Just a word about the plastics parts. Parts will come supplied in the orientation best required for printing. So basically you shouldn't have to worry about figuring out which way should be down on the bed. The part numbering is such that the first part of the part number is the part number, and the second part is the percentage of fill required for that part. Okay, so for the control box and the motor box end of things, if you'll need part numbers 1 through to 14 to do this. If we start off first of all with part number 2, which is our battery bay, and if you print with it part number 14, I think it is, which is a strap and 4 of these small tabs. So the first thing really is these tabs, I've put 3 of them in there already. You'll need a pair of tweezers. Yeah, so if you look at the part, we have these 4 tabs to go in here. I've got 3 of them in already, and basically you'll need a pair of tweezers. Take the small tab and the tweezers, find the relevant slot, put that in there, and just press the tab home. Now I don't glue these tabs, as I've said before. If they break off, getting the battery in and out, then you can just print another one and drop it in there. Next we need to take our Digital Bird 2-prong NP style battery board, which will come like this. And I think it's a 120mm long cable on it. And if we turn to the back of the battery bay, you can see that there's a slot along here and a second slot up here. The first slot is where the cable goes in. It goes this way round. The prongs fit in, and it should just drop down and press firmly into that hole. Now the slot at the back is for this cable, and you can run that cable in there. And what I like to do generally is put a little bit of hot glue on the top of that cable just to keep it in there. And you take a battery and just check that when your battery goes in, that the prongs meet. Okay. So the next thing to do is take part number 1. This is probably one of the bigger parts, but you'd be happy to hear that it only has to be printed at 25% fill. And if we look at that part, the hole in there is for this battery bay. So the battery bay goes from the inside, comes in and just slots into here and comes forward. And we turn it round, you can see that that's how the bay works. Okay. Now to fix that in place, we just use some super glue, and what we need to do is glue around this edge here, the front, this back area here, and down these. So in other words, that area here and the front. Just run some glue around here, all the way around that top plate there, and on that front edge here. Like so. And without sticking it to your fingers, drop it in, push it all the way along, and wait for that to set. Okay, I forgot to say as well that if you prefer, you can now download all the parts for the Digital Bird system from the Prusa Printables website, as well as the Thingiverse website. And there is a fuller description of this build as well on the Instructables, that's the Autodesk Instructables website. Okay, so the next step is to take our Digital Bird mainboard. Okay, so it only requires 1 driver on this board for the jib, and our ESP32, and that slots in here. Now it goes in and has to turn underneath this protrusion here, which is for our encoder. It can be a bit finicky, but it does go in. There you go. Okay, so that sits in like that, and you can use two of these small screws. You won't be able to reach the ones in this corner, but it doesn't really matter. It's fairly in. It's just to stop it rattling around. You put a screw in this one and a screw in this corner here. Can you find it tricky? Okay, so that's in there quite firmly. So the next step is to take our small toggle switch that goes through this hole here. And you don't have to glue this, it should just be a simple press fit home. So next we want to fit our OLED display. Now our OLED display is paired on the same plug with our AS5600 encoder. So you can just take that off of here just now. And your OLED display goes in this top window here from the inside. So with the plug at the top, it should just go in here like so. And then take your strap from part 14, and the strap just goes in there and presses down, and it goes past the OLED like so, and there's a slot down at the bottom there that goes into as well. So next we can take our shutter 2.5mm shutter release jack, and that goes into the top hole here. Okay, press that through the hole. And what we can do then is just put a little bit of super glue around the inside lip of that and make sure that that goes all the way home like so. Take our jack home. So the next part, we can take our auxiliary power socket, looking like this, the yellow end. That goes into that one. Just let our socket drop in. So getting back into here, we can start plugging some of these in. So the blue end goes into the blue port. The red power harness can go into, a red battery harness rather, can go into the red port. So that goes into the red port like so. Our yellow comes along here and into the auxiliary power port. And your black switch cable goes into the black socket like so. So setting that aside a moment, our next step is to find this piece, which is part 004, and this is the support really for most of the other components that come, the drive components that come out. Now we're using limit switches on the boom, and in the kit you will get a cable with two of these micro limit switches, and if you look on the top of this part there is a position for each of these. So looking at it that way round, you take your furthest, the one on the end, that drops into here, okay, and your cable leads into that slot. It's probably easier to put the cable in first. Limit switch goes into there. Cable leads out and goes through that hole here. Okay, looking like so. Tuck that wire in. And we use these 11mm long, here's an 11mm long self-tapper. And you should see 2 holes below here, and we can just screw these down into place. On this side of the part, there's a hole here for one of these bearings, which is a 5 by 16 by 5 bearing, and that just drops into here like so. Okay, and that's that part pretty much ready to be installed. Next, we can take our cog. Now our cog is in 2 parts. Mine is already glued together. Basically, you run any 5mm through here, put some super glue on the face of the top cog, bring the 2 together on the bolt, screw it up, and you end up with Okay, so my microphone seems to have stopped working, so I'm going to have to do a voiceover on the next few parts of this video. Find part 00325, which is the drive side of the motor box, and we're going to insert a 30 by 42 by 7mm bearing into the seat provided. Now, the usual is the case, this side of the part will have been the bottom, so you'll need to scratch around the edge just to remove any spread so that the bearing fits easily into the hole. And it's worth just running a small file around that inner edge as well, just to get rid of any nuggets of plastic that may have built up on there. Then we can just press the bearing home, and it should be a fairly straightforward press fit. So next we need to find part 00530, which is the stepper motor cage, and that fits on like so. And if we take 3 of these 40mm long M5 low profile bolts and bolt them through the holes provided. And make sure that this cutout here in that cage, which is for the cable, is on that side of the part and not around the other way. Now we can take a 50mm long low profile bolt and we place it through this bearing here, ready to receive. Put a couple of washers on first, M5 washers. And then we can take our GT2 timing gear and run that onto the end of that bolt, like so. Now we take our 200mm long GT2 timing belt, run that through. We take our NEMA 17 40mm long with the 20 tooth cog on there, noting that the thicker part of the cog is at the top of the shaft. That goes down to that hole, okay, with the cable coming out that way. Turning it over, put the belt around the timing pulley. Then we take the side of our motor box, and the 2 should just come together with the and you should see the timing pulley pop through that hole like so. Now we can take 2 of these 50mm long low profile bolts, and the 2 holes in the side of the motor cage. If we screw these into here, and what we're going to do with these is by screwing these in, we are pushing the NEMA 17 back and tensioning the belt underneath. And the second screw really just fixes the stepper motor in place. feel inside there, you should feel how tense that belt is. If you need a bit more tension, just continue to tighten the screw up and push the stepper back a little further. So now that we have our stepper in place, we can add our small encoder magnet, which is diametrically magnetized across the face, and it will come in the pack with the encoder. It's a special magnet. The north and south are split across the same face, not north on one face and south on the other, as with a conventional magnet. And it can be helpful to drop a little bit of super glue on there just before you drop that magnet onto place at the back of the stepper. Now we are ready for our damper cartridge. Now our damper cartridges are provided already made up in the kits. If you haven't purchased the kit, then you'll need to make this up yourself from parts 10 and 11. Smear some heavy damper grease onto the inside faces. I use Triple Zane 320 Blue, which is about £30 per 100 grams. It's pretty expensive. And before you put the cartridges together, you'll have to add a 20 by 27 by 4 bearing. As you can see here on the video, the bearing's already in place. Now there are keyways in the hole that the damper cartridge goes into, and those match the keyways on the damper cartridge itself, and it's worth just taking a file and just making sure that everything's clear for that before you press it home. So find lower jib arm end support seat part 00860 and push in a 5 by 16 by 5mm bearing into the inside of the part, like so. On the reverse of that part, drive in a 40mm long M3 cap head bolt into the part so that the thread is all the way under the plastic, and it should leave it protruding about 25mm. This is going to activate our limit switches for us. So this part comes together like so, with that going into the slot, and as that arm moves up and down, it will that screw will hit the limit switches. From the inside of the assembly runs through an M5 cap head bolt 60mm long through the damper cartridge, and add an M5 nylock nut onto the end of that, and just tighten it up enough so that it prevents forward and backward movement. Don't over tighten. So now we can find part 00760, which is the upper jib arm support, and aligning the keyways, press it home onto the inside face of the gear coming through the hole. Add another M5 nylock nut on the other side, and again just tighten it up enough so that the assembly doesn't pull back and forward on the shaft. So now we're ready to install our AS5600 encoder into this side. Now it's a small board encoder, and the small chip on the top of the encoder here is very important that that aligns with the magnet in the back of our NEMA 17. So we measure from the case there down to the center line of our magnet, and we compare that measurement on the lower case and make a small mark. Okay, so once you're confident that your AS5600 chip is lining up with your the magnet on the back of your NEMA 17, I find the easiest way of fixing this chip into place in a way that can be adjusted is just to use hot glue. The holes in these boards are quite large, so it requires quite a large screw, and we don't have an awful lot of plastic behind them. So once that's in place, and I'm confident it is, I just squirt some hot glue in behind into each of these holes. And that's enough. take off any major surplus. And if we need to get that out of there to readjust the position, the hot glue, it can just be peeled off. You know, the thing will pop out and the hot glue will peel off out of these, and we can change the position and put it back without destroying the part. So while I've got the hot glue out as well, this cable here, the cable for the power, I'm just going to put a little bit of hot glue on top of that just to keep that in place. Okay, so with all that done and everything firmly in place, we can test this now. If we take a battery, we should see the light come on here, and on the side we should see our percentage of our battery available and the ID for this particular device, the PTZ ID at the top, and what battery we've got left. So now that I'm confident that the board and everything here is working and it's getting power, so now it's time to bring the two parts together. What I've done is I've plugged my limit switches in here, the orange cable. I've plugged my stepper motor in from this half into the board here in the stepper driver. Your gasket can go over like so. It's the part that runs between the parts. Now this big slot down here is for one of our kilogram weights, and you get a pattern from that from the system. But basically you're always going to need at least a kilogram and preferably as far out on the boom as possible. So what I've done is built at least one of the weights into this box. So that weight simply drops into here and goes all the way down. And the hole will align with a hole in here, which I'll explain later. So now we should find that keeping those cables out of the way, we can bring our two halves together. Like so. And then we take 4 of our 50mm low profile bolts. Now what I suggest to you at the moment is that you only put in 2. The other 2 that are on this corner and this corner, once you know everything is working and you're not going to have to take the thing apart to make any changes inside, then you put those 2 bolts in. But for the time being, we'll just run 2 of these bolts in here. Not that I'm not confident or anything, but you know, things don't always work first time, and it can be really annoying having to take out 4 long bolts. So now that our drive box is assembled, we can do a quick test. We can power up. Now the 2 arms aren't linked yet, so we'll have to manually activate the limit switch. But if we power on, we should see the top arm move up, and then we can manually activate the limit switch.